Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 7.6, Solve Systems of Inequalities by Graphing. We need to graph the following systems of inequalities. You need to graph both inequalities in the same graph here. So the first step is we're just going to go ahead and graph these. So the first graph I'm going to do is y is greater than x minus 2. Start at x minus 2. My slope says it's 1 over 1, so I go up 1, right 1, down 1, left 1. And I'm going to go ahead and graph that. Remember, if it is just greater than, which it is here, it's not equal to, I need to have a dotted line to graph this inequality. So as we go through, we've got to make sure we have a dotted line. All right. Now I'm going to use red for this inequality. I'm going to use blue for the second inequality. Okay. So the second inequality is y is less than or equal to negative 1 over 3x plus 3. So if I start at positive 3, my slope tells me to go down 1, right 3. So then I would go up 1, left 3. And because it is greater than or equal or less than or equal to, I'm going to go ahead and make a solid line for that graph. All right. Now, what we have to do is we have to figure out where the solutions would be. If you remember from our last section, to figure out where the solutions are, we have to shade above or below each line. So to shade above or below the red line, which is y is greater than x minus 2, I'm going to put 0 in for y. That is greater than 0 minus 2. If that is true, then I'm going to shade to the side of that line that has 0, 0. Well, I have 0 then is greater than negative 2, which is true, which means I'm going to shade up towards 0, 0. Now, I don't want to completely shade that yet. I'll show you why in 1 second. I'm going to draw those arrows so I know which direction I want to shade. Now, the blue line is y is less than or equal to negative 1/3 x plus 3. So again, I'm going to put 0 in for y. Less than or equal to negative 1 over 3. If I put 0 in for x plus 3, anytime I multiply by 0, it will be 0. So 0 plus 3 is 3. Since that inequality is also true, that means that I'm going to shade towards 0, 0 from the blue line, which is down. Now what I want you to see is there is a section where the arrows are pointing at each other. And that is going to be, I'm going to shade it in green so you can see it. Notice that this arrow is pointing down, this arrow is pointing up. So because they're pointing at each other, I'm going to shade in between the two lines where the arrows are pointing at each other. So what we have for our solution set is the blue line starting from here, from that area, the blue line, everything below it down to our dotted red line. The dotted red line is not a part of the solution. It's everything above the dotted red line up to the solid blue line. Okay. On to number 2. Again, I'm going to use red for the top equation. I'm going to use blue for the bottom, or inequality, I'm sorry. Use blue for the bottom inequality. So the top inequality is already in this the form that we need, which is y inequality mx plus b. So I'm going to go to negative 5. It's up 2, right 1. It's down 2, left 1. Now again, that is not equal to, so this is going to be a dashed line, dashed or dotted line, however you want to think about that. So we have a dashed line. For our blue equation, that is not in the form that we need it yet. We have to solve for y. So if I subtract 3x, I'll end up with 4y is less than or equal to negative 3x plus 12. From here, I need to divide by 4. So y is going to be less than or equal to negative 3 over 4x plus 3. So I start at positive 3. I'm going to go down 3, right 4. I'm going to go up 3, left 4. And this equation does have an equal to, or inequality, I'm sorry, does have an equal to. So this will be a solid line. Again, we have to check and see where we need to shade from each line. So in the top equation, if I put 0 in for y and I put 0 in for x, we end up with y is greater than -5, which is true. So I will shade up towards 0, or the side that 0 is on, which is kind of our upper left side of that graph. For the blue equation, I have 0 is less than or equal to -3/4 times 0 plus 3. So 0 is less than or equal to 3, which is also true. So I'm going to shade in the direction of 0, 0 from my blue line, which is down. Again, now that I know what direction everything is being shaded in, I'm going to shade in the area where the arrows are pointed at each other. So that will be this big section here. Again, the blue line is part of our solution set. The red dotted line would not be part of our solution set. So how do we know where the solutions are? Well, that is where the shading overlaps. Let me show you that real quick. What I mean by that is to shade on that blue graph of problem number 2, I would shade everything below the blue line, right? To shade the red graph, I would shade everything above the red line. You don't have to do this, just pay attention. So now where our solution would be is where our shading overlaps, which is the green area that I shaded earlier. If I can go ahead and get rid of the shading of the red and the shading of the blue, you'll see that our green area is the area where our two shadings would have overlapped, and that is our solution set. On to example 3. I have x is greater than or equal to 3. I'm going to use red for that graph. I will use blue for y is less than -2. Remember when we graphed linear equations, if I had x equals something, it's going to be a vertical line where that x is. So I'm going to start at x being 3. It's going to be a vertical line, and because it is greater than or equal to, I will draw a solid vertical line right at x equals 3, or x is 3. For my blue graph, remember if I had y equaled something, it would be a horizontal line where y is -2. Well, that's where y is -2. So it's going to be a dashed horizontal line at y is -2 because it is not less than or equal to, it's just less than. Now I need to figure out where to shade. For the red graph, x is larger than 3. So where is x larger than 3? It is to the right, because that line is where x is 3. So everything to the right of that is larger than 3. For the blue line, y is less than -2. Well, our dashed blue line is where y is -2. So it's going to be everything smaller than -2. I'm going to show you how these overlap real quick using our entire graph this time. So the blue would shade down here. The red would shade over here, which means the area where it overlaps is underneath the blue dashed line and to the right of the red line. So the green is our solution set. It will include the red solid line, but it will not include the dashed blue line. Okay? Now on to a story problem. Now the story problems, we're going to treat these very, very similar to how we treated the systems of equations that we were doing not too long ago. So suppose you need $2.38 in postage to mail a package to a friend. You have 9 stamps. Some are 17-cent stamps and some are 34-cent stamps. How many of each do you need to mail? The package? So first we need to make our variables. Well, we're going to make x our 17-cent stamps, and we'll make our y our 34-cent stamps. Now that I know what my variables are, I need to label my graph. So the y, which is our vertical axis, is my 34-cent stamps. The x is my horizontal axis, is my 17-cent stamps. Okay? Now we need to make our system of inequalities, which is the same situation as we used when we made a system of equations. So what we're going to do is first, I want to figure out the total number of stamps. So to figure out the total number of stamps, just like coins, I'm going to take my x plus my y, and that's going to be something with 9. Well, here's the situation. You have 9 stamps. So I can use 9 or less, 9 or fewer stamps. So x plus y must be less than or equal to the 9 stamps I have. You need at least $2.38 because $2.38 is how much you'll need to get the package to your friend. So what we're going to do here is I'm going to take the price of our X stamps, which is 17 cents, plus the price of our Y stamps, which is 34 cents. That needs to be greater than or equal to $2.38. The reason for that is, again, it takes at least $2.38 in order to get the package to our friend. Now, I don't really want to mess with inequalities with decimals if I don't have to. So what I want to do here in order to get rid of my decimals is to multiply that inequality by 100. When you do that, you end up with 17x plus 34y is greater than or equal to 238. Because I've made both sides of the inequality multiplied by 100, I haven't really changed my inequality at all. I just got rid of the decimals doing that. Okay. So now I need to get y by itself for both of my inequalities. So for the top inequality, which I'll use red when I graph it, I'm going to subtract the x. So y is going to be less than or equal to negative x plus 9. Here's 9 on our graph. Negative x means down 1, right 1, down 1, right 1. It's less than or equal to, so this will be a solid line all the way down to 0 stamps. Now, for my second inequality, I'm going to use blue, so I'm going to go ahead and finish my work in blue. First, I need to subtract that 17x, so it would be 34y is greater than or equal to negative 17x plus 238. I would need to divide by 34. So y is greater than or equal to negative 1/2 x plus 7. Now that I have that equation, I'm going to go ahead and start at 7. It's down 1, right 2. Down 1, right 2. It is greater than or equal to, so that will also be a solid line. Now, I need to figure out where to shade this in order to figure out my solution set or my possibilities of how many stamps I would need and of what type. So for my first equation, first inequality, which is y is less than or equal to negative x plus 9, which is our red, it is our red line. It's going to be less than our red line, so everything below that. For our second, which is our blue line, it's going to be greater than, so it'll be above the blue line. So if I shade everything above the blue line and everything below the red line, what I end up with is an area right here where they overlap. So that green area is where our solution set lies. Both the blue line and the red line are part of our solution. So that would be how we could figure out how many stamps I would need and of what type. So I would need, if I had 7 34-cent stamps, then I would not need any 17-cent stamps. But if I only had 5 34-cent stamps, then I would need 4 17-cent stamps. That would be how you would read that. So you could figure out exactly how many of each type of stamp you would need in order to be able to send your package to your friend. Well, that is the end of our video. Remember that when you are solving systems of inequalities by graphing, you need to graph each line just like we would have if it was a system of equations. We are going to figure out where to shade them based off of whether it is greater than or less than, and our solution set will be where the shadings overlap. If you have any questions over this material, please make sure you come in and see me. Otherwise, thank you very much for watching the video, and have a great day.